Okay, so I had to do a second part on this question. My audio got corrupted for some reason when I started part D. So this one says, what is the probability that the actual weight is within 0.5 grams of the prescribed weight? So that means we could either go, the prescribed weight was 3, we'd either go up 0.5 or down 0.5. Now there should be symmetry around 3, because if you think about that being our point where the area is 0.5 on each side, because we already kind of saw that when we did greater than the 3. We are looking at, we could do all that we could do from 2.5 up to 3.5. You can do that integration or use our CDF. Or we could look at it as just do one of them, just from 0.25 to 3, that's half, and then double the answer. So that's the route that I'm going to go. So if we look at part D, and it doesn't matter which half you do, if you do 2.5 to 3 or 3 to 3.5, they're both going to be equal because they're both a half step away from our line of kind of symmetry here. So let's say we want to do the 2.5 to 3. Okay, so you could think of it as integration if you want to do that, or you can use the CDF. If you use the CDF, you would say big F of, and you use your bigger one first. So that would be the 3 minus big F of 2.5. And then we're going to plug these into that function we came up with. Okay, so we have 3/4. And then we would have negative, and then it's 3 cubed, so that'd be 27 over 3. We have 3 times 3 squared, so that's going to be positive 27. And then we're going to have negative 8 times 3, so that's negative 24. So there's my first one. Minus, now again, I'll have the 3/4 out front because we're plugging into that CDF. And then we're going to be working this out on our calculator because this one's not going to have nice values since it's a 0.5. So you need to do 2.5 cubed off to the side on your calculator. So I'm going to get that this is it has a negative in front of it. So it'll be negative 15.625 on the top divided by 3. And then I'll do 2.5 squared, which comes out to 6.25. We have to times that by 3. So then I'll have a plus 18.75. Again, you need to work these out kind of on the side as well. And then we have our minus 8 times the 2.5. That's going to come out to a negative 20. Okay. Now you could pull the 3/4 out to the front if you want to, because I'm just evaluating this part yet. I'm not doing the doubling yet to take care of the whole area. But if you do that, then you can kind of combine some like terms. If we combine, and I would go ahead and distribute your negative in that second parentheses as well. So this is going to distribute and change all of our signs throughout here. So negative 27 over 3 is just negative 9. I would probably go ahead and reduce that. So that's 27 and a negative 24 and a negative 9 in that first parentheses. That's going to come out to negative 6. And then again, we pulled the 3/4 to the front. We're going to have this positive 15.625 over 3. And then we have these two that we need to add together in that second parentheses. That's 20 minus 18.75. That's 1.25. Okay. Now we're going to work this out. So if you do the fraction part first, that'd be 15.625 divided by 3. And then we're going to add to that 1.25, and we're also going to add the negative 6. That gives me some really long decimal inside my bracket. It's like 0.4583 repeating. I'm not going to write that down because we're just going to times that by the 3/4 or the 0.75 out front. So when I do that, this whole thing equals 0.34375. Okay. And then that is just the half. That's just from 2.5 to 3. So if we double that, we'll have, so this was the probability that we were between 2.5 all the way up to 3. If we double that, we'll have the area that we're 2.5 to 3.5 since the symmetry exists. So if you double this, you're going to get the final answer, which is 6.875. So 0.6875. So we write that in here, 0.6875. Okay. And then for part E, this is the last part. What is the probability that the actual weight differs from the prescribed weight by more than 0.6? Okay, this is a little different. When you see these more than the kind of middle or more than your mean or something like that, you're going away from it. So if you think about it, you need to figure out, first of all, if you're at your center, what is minus 0.6 from that and what is plus 0.6 from that, because we're kind of figuring out where the boundaries are. It's going to be 3.6 and 2.4. Now that's 2.4 and there's 3.6. We are not going in between these. We are actually going out to the edges forever. Okay. So you can kind of, I mean, we won't get any values once we're at the 0 part, but we are going away from our center of 3 by 0.6. So we have two different evaluations need to be done. Now they're going to be symmetric because again, they're exactly the same away from the center. So you can still do just one of them in this scenario and just double it. So let's say, and we only need to evaluate from our starting point where we actually have some area values. So I'm going to do from 2 to 2.5. And I'm again going to use my CDF. So 2.5 is the bigger one minus big F of 2. We already did the 2.5 a minute ago, so I'm just going to bring down the values from that one. That was this 3/4. We still had that out front. And then this time the negative's not going to get canceled because this isn't the subtraction step, but we need to write it in. Write my equal sign a little further away. Equals 3/4, and then this is negative 15.625 over 3. And the original was plus 18.75 and then minus 20. The only reason we changed the signs was it was the second parentheses before. Then we're going to have our second parentheses, which is minus the evaluation here. So this is 3/4. That would be negative 8/3. And then that would be 12. We already did this one earlier too. And negative 16. Okay. So we've got all of this. All this together. And like I said, we work this out and then we can double it. So you can, again, if you want to, bring out the 3/4 to the front. You just have to remember that you need to distribute that negative for that parentheses part, the subtraction step. So distribute that to all of these. So then I've got my fractions. So let's add those together. So we've got a negative 16 or 15.625. And then we've got a positive 8, and that's going to go over 3. So that's negative 7.625 over 3. And then I'm just going to add all my decimal numbers together because that's just easier. So we have 18.75 minus 20, and then we have a minus 12, and then we have a plus 16 because that was after distributing those. So that's plus 2.75. Then we'll work on that and then times it by the 3/4. And remember, that would only be that 1/2 from 2 to 2.5 essentially. So 2.75 and the other part added together. Let's see. It's going to equal a big long decimal again. It's like 0.208 and then 3 repeating. Times that by the 0.75. And now this is where we get a nice number. It's 0.15 625. Now that seems a little big. Let me double check. Let me double check the math on that because that seems a little too big. I want to say it should be closer to 10. So we had 2.5 cubed. Let's just double check the numbers. And this is always the reason. So that is 15.625. And then we had 2.5 squared times 3. That's 18.75. And then we had 2.5 times the negative 8. And I'm just checking because something didn't go right in the math part. I believe this is smaller than what I'm getting. Okay, so these three numbers in the first parentheses are all correct. Let me check the second group. So we would have plugged in 2. So that would have given us 2 cubed is 8, and then it's a negative, and then we get it over 3. 2 squared is 4 times the 3 that was already there, which was 12. And then 8 times 2 is 16. Okay, so it must be something I did when I added. So 15.625. And then we had that 8 to add to it. That is the negative 7.625, and that's going to be divided by 3. Let's double check all the other numbers. So we had an 18.75 minus a 20. That's negative 1.25. And then we're adding to that the 16 but subtracting the 12, that does equal 2.75. 7.625 negative divided by 3, and then add 2.75 to it. That's where I guess, no, that's 0.2083 repeating. Okay, it's 0.15625 is what we're getting there. But, oh, this was 2.6. That's where I messed up. Or 2.4. Sorry, 2.4. Okay, I caught it. Sorry about that. Let me re-crunch the numbers real quick. My line looked like it was drew on the 2.5, but we came up with 2.4. So we just need to redo that first parentheses. That's why it was coming out too big. We should be getting around 10% for this one. I already worked it out before. So let me fix the math right here because it's going to be this portion that's wrong. When we plugged in, it should have been 2.4. I bet y'all caught that while I was making a mistake, and that's okay. So we've got 2.4 cubed, and then make that negative. That's going to be negative 13.824. Okay. And then we're going to have 2.4 squared and times that by 3. That's plus 17.28. Yeah, so our numbers are already going to be a little smaller than they were. And then we have 2.4 times 8, which is negative, and that's going to be 19.2. Okay, re-crunching this part because this is the correct values now. So always be careful because it's super easy to make mistakes when you're looking at a bunch of work all together. Even I make mistakes. So we have 13.824, and that's negative, and we're going to add to that the 8 in the second part that both have the denominator of 3. So that's negative 5.824 over 3. And then I need to add all my decimals and pieces. So 17.28 minus 19.2, and then minus the 12, and then plus the 16. That's plus 2.08. Okay. Now we're going to work out this part in the bracket. So negative 5.824 divided by 3, and then plus 2.08. That's going to be 0.1386 repeating, but then we times it by the 0.75. Okay, and this is where we get the, it's like 0.104. Okay, that's what we get for that part. That's what I was expecting, around 10%. So once you get this, remember we said that this was just the probability that we were between two, essentially anything from 0 up to 2.5, or actually from negative infinity to 2.5, because but it's only defined essentially from 2 to 2.5. So if we double that, that'll give us the area on both sides where we are 0.6 away from the center, the symmetry line. So 2 times 0.104 is 0.208. Now they do tell you to put 4 decimal places on here, so it shouldn't count it wrong if you don't put the 0, but you can add the 0 to make sure you have 4 decimal places. So 0.2080. All right, that's going to be the end of this video because these problems in this section, I only have 3 for 4.1 to 4.2 because there's just so much integration. I'm going to do a second and probably a third video for the next 2 problems.